Hello and welcome back to ChatLoopBackOff, weekly CNCF live stream showcasing a lot of the CNCF projects that you might already know or might be interested in. So in this show, someone like me comes on and takes a look at this project sometimes for the first time, or sometimes takes a look at it back again after some time. My name is Mofi. I'm a developer advocate at Google Cloud, focusing on Kubernetes as well as running AI and ML workload on Kubernetes. And this week, we're taking a look at CubeArmor. So this is a project that is one of the security-centric project on CNCF. So in a second, we're going to have the screen back up on the screen as well, so you can start taking a look. And the magical person in the background will do that for us any moment now. Here you go. Our screen is being shared right now, so you can see we're going to take a look at CubeArmor. A couple of other things I would like to announce and let you know. If you already didn't know, Cloud Native SecurityCon North America is happening in a few weeks, about 5 weeks, 5 days, 22 hours, and 58 minutes. We're going to start Cloud Native SecurityCon. So you're going to have a lot of folks coming on, talking about Cloud Native security, some of the new inventions or things that are happening, as well as challenges and other best practices and lessons learned and all sorts of cool stuff. So if you are there, do check it out. And if you're in the chat, also come say hello. If you are a user of CubeArmor or of something similar, let me know what do you like about it, what you don't like about it. For me personally, have not used CubeArmor to that level of detail before, so it's going to be learning for all of us. We're going to take a look and see how CubeArmor works and how that works. And again, we're going to take a look. CubeArmor works across VMs and other things as well, but in this stream, we're going to look at CubeArmor in the context of Kubernetes. I mean, Cube is in the name of it, so it's kind of implied that CubeArmor would work pretty well with Kubernetes. So that's one announcement of Cloud Native SecurityCon being there. If you are in Seattle area, or if you're interested in traveling or any of that sort, please check it out. I think tickets are still available. Yeah, so awesome. Let's get this show started. So CubeArmor. So CubeArmor, from their own website description, it is a runtime Kubernetes security engine, uses eBPF and LSM, fortifying workload based on cloud containers, IoT edge, and 5G networks. And it enforces policy-based controls. Now, in terms of securing a Kubernetes cluster, there is obviously a lot of different aspects of it, right? So you have your network policies, you have your pod security policies. So CubeArmor adds one more additional layer on top that lets you do some cool stuff. I was looking at it again earlier today, just preparing for this situation today. So it looks like CubeArmor targets Kubernetes containers, KubeVirt, which is running. Actually, interestingly enough, in a couple of weeks, I'm going to come back and talk about KubeVirt. So it's going to be interesting to take a higher, one level lower look at what KubeVirt is and what it does. But today we're looking at how CubeArmor interacts with Kubernetes and containers. And a lot of the things CubeArmor does, it seems to do them using tools like eBPF and LSM. So eBPF lets them kind of plug into the Linux kernel, look into what's happening. And one of the key interesting things they mention in their doc is CubeArmor does things before. So this part right here, inline mitigation and post-attack mitigation and its flaws. So CubeArmor does not do something like action happens, you track that has happened, and you stop that from happening anymore, or kill a process. So in this image, if we take a look, as a pod starts, a process starts, you have some syscall or trace point or some probe that checks, hooks into eBPF, that creates an event, and the event handler realizes that this particular task that this pod is trying to do is something malicious or something that is not permitted. And then you send a delete or kill command. But by then, the process already had started. So again, in most cases, this is fine if we just can manage to kill it very quickly. But even then, the process actually got some CPU cycle. Inline mitigation, on the other hand, kind of looks at the policy that are set in the cluster and can say things like, okay, this particular thing we're trying to do is not permitted to do, so the process itself is not going to spawn. So which is a better way if you can just stop something from even happening. We're getting ahead of ourselves, so before we do any of that, another thing I would like to do for a project like this is also look at their GitHub and see kind of the activity, how many people are using it, what kind of traction they're getting in terms of how often issues are created, how quickly issues are reported and discussed on. So open this up. There is about 145 issues open. In most cases, again, depending on how long they have been open, this is generally a good sign. More people are using them. That's why issues are being created. So, for example, in the last week, 3 weeks ago, last month, in the first page, out of about 50 or some issues, or some number of issues, the oldest one is February 6th. Most of them seem to have some sort of comment. Some of them does not have as much comments as I would like to see, but that generally means, again, this one has 6 comments in a couple of weeks, so that's pretty good. Next, I would like to take a look at the pull requests to see kind of like, again, they closed about 1,000 of them. That's pretty good, and that also kind of gives you a idea about the. I feel like the I don't know, health of the open source project. Like it is getting constant new changes requests. I mean, again, new changes doesn't necessarily mean the project is doing well. Changes can also mean things are broken and people need to fix it. But oftentimes, if a community is engaging with something, they would come back with new ideas and try to add new things, or bugs will be getting fixed, things of that nature. So you can see there are a number of them here. There's some feature proposals, work in progress. Some of them has a bunch of conversation happening. Oh, SBOMs, software bill of material stuff. Okay, cool. Cool stuff. Last thing I would take a look at for a project like this is also their release cycle. Like how consistent are they with their releases? Because again, it's a security-based tool. If they let it go too stale or the release are not in some sort of proper cadence, it might be difficult for you to adopt a tool like this. Okay. So you have 138 that came out. When did it come out? Oh, 2 weeks ago. And then the one before that was last month. Then you have last month again, March 15th, March 8th, February 12th. So they have a pretty good cadence every month where new things are coming out, which is pretty cool. Awesome. So that's the open source project there, about 1,300 stars. One thing is, I think GitHub stars is a bit more skewed because some of the, like, I don't know, something like front-end framework of some kind would, like, in a month or like a year would amass like 50, 60,000 stars. And then all of a sudden, the value of GitHub stars is kind of skewed in our mind. But you have to understand, like, this kind of a tool like CubeArmor probably would be something that are not used by everybody, right? Every software engineer does not need to use CubeArmor. It's more like platform folks that are using it. So 1.3K star might not be like the most stars you have seen anywhere, but it is a pretty good number. Project has been around for a few years now, a good number of contributors. So these are all good signs to see the project is growing and pretty healthy. You have also, it's a cloud native sandbox project, so they're probably going through their cycles of getting it graduated at some point. And the last thing is also, it is on a full version, so they're claiming to have like a proper full version 1.0 release at some point. This is also a good sign for you to kind of choose to adopt a project like this for things. All right, so well, we're not here to see how well their GitHub is set up. We're here to see how this thing works. In that effort, what I have done is I have a Kubernetes cluster ready to go. I spun one up on GCP, GKE. But if you look at the support matrix for KubeArmor, obviously GKE and container optimized image works. But bunch of other images of obviously work. You have from AKS stuff work, EKS, IBM, Oracle here. You see Red Hat OpenShift, Rancher Labs, Oracle, again, VMware. So pretty much any Kubernetes distribution, including your own on-prem stuff, you have this compatibility matrix that shows things like observability, audit rules, blocking rules. All of them are kind of supported. There are a few things that are not supported here and there, but for most use cases on GK, everything is supported. For bare metal, everything is supported. So you are in good hands if you are choosing to adopt CubeArmor and looking for all the support metrics. Looks like most of the things are mostly supported. Some of the things, I don't know what each of these signs mean. Like this probably is either blocked or in progress, most likely in progress. This one does not work or something. This is for Oracle. Blocking rules won't work on the Oracle images. Oracle MPR images. So Oracle has multiple types, I think. Yeah. So OKE, it works, but MPR, it doesn't work. All right. Also, Linux distribution, pretty much all the major ones from Debian and Ubuntu works fully. The one Amazon Linux, full support there. Alibaba Cloud Linux, full support. Arch Linux, full support. Works on Raspberry Pi. That's cool. Fedora, Red Hat, mostly works. CentOS, older version of CentOS, seems like there's a partial support there, but other than that, you pretty much have full coverage on all Linux distribution. Sounds good. Okay, now let's this I was reading this right before, so we were talking about this when we started, but the main idea there of being inline mitigation, of stopping something from happening before it gets run on the cluster versus not, that seems like an interesting idea. If you can kind of have policy rules, look at it and say this should not be allowed to even get scheduled on the cluster, that's useful. And this is talking about the problem with Kubernetes native pod security context. So in Kubernetes, you could set some pod security context that adds some security context in every single spec. So you can set seccomp, AppArmor, and other different capabilities that you allow or deny for individual pods. So what do they think is the problem there? Okay. All right. So one thing is individual cloud providers and Linux distribution have their different versions of LSM, Linux security modules. So when you're creating this policy, you may or may not know whether or not this is going to work in the target environment. So if you want to create a Kubernetes distribution that is more portable, if you want to take it from one cloud provider different, or move between data center and cloud provider, or move between different cloud provider, there might be situations where you might not have exactly the same LSM available across all your different distribution. Again, this is something you can probably fix just by like making sure you have all of this, but that they call out to be a problem. Next one is BPF-LSM is not supported by pod security context. So this is what they use. BPF-LSM is, again, nice to have before you can start something in the kernel. You can have a probe listen for it and stop it. So that's one of the key advantages they're claiming to have over there. And finally, it's difficult to manually specify an AppArmor SELinux policy. This I can agree with. Like writing, again, I'm not an expert in writing AppArmor SELinux policy. So if CubeArmor can make this process easier for me, that would be a big win. That's awesome. And I think in addition to like difficult to predict which LSM is going to be available, kind of rolls into the multi-cloud deployment situation. Like Google Cloud has one, Amazon has one, and like then this other worker has a different one. So you kind of have to, instead of being able to take advantage of the best in class LSM available in each cloud, if you have multi-cloud situation, you end up with the lowest common denominator. You kind of look at what is common across all of them and you just take those, and you open yourself up to by not using the most secure LSM that is available to you. All right, cool. So differentiations looks pretty useful there. Again, if you are feeling these kind of challenges of using security modules like SELinux or AppArmor in your own clusters, I would take a look at this again. If any of these problems resonate with you more, that would be useful. You can also do directly on VMs and bare metals. We're not going to look at that today, but you can. So what we're going to do, I'm going to go through their getting started page. I have done a couple of the steps before just to have a quick start, which is I installed CubeArmor and I installed KArmor, the CLI tool. So let's go jump into the terminal, bump up the font couple of notches because this is always useful to have bigger fonts. What I have is kubectl get nodes. You can see that I have a Kubernetes cluster with 3 nodes that I have spun up about 2 hours ago this afternoon as I was looking into getting prepared for talking about this stuff. Next up is I installed it. So if I do kubectl get namespace, you would see that I have a new namespace, which is the CubeArmor. All the other ones comes with the cluster itself. As you create the cluster, you have all of this stuff. GMP is Google's managed Prometheus. We have Cube Public. Cube System has all the system pods. Other than that, I don't really have anything else installed running in this cluster. If I do get PO on the default nodes, nothing is running. But if I do get PO dash and CubeArmor, you would see that bunch of things are running in the CubeArmor namespace. The first one here is this particular pod that are running, which is CubeArmor BPF container D. This one is daemon set. So daemon set in Kubernetes, what it is every time a new node comes up, daemon set runs one copy of that particular pod or application into each of the nodes. So this makes sense for it to be a daemon set. This is the BPF probe that is running on your cluster. So every node has one of these containers running, so that whatever happening in your cluster, each of in the node, this container can kind of have this probe set up for it to collect the information it needs. CubeArmor operator also got installed via Helm, and finally CubeArmor relay. I'm going to assume operator does all the management level stuff for CubeArmor, and the relay does probably moving things between like logs or telemetry and all that stuff. Haven't looked deep into exactly what they do yet. We could probably take a look at the log of this. So if I do -n CubeArmor, let's see. Yeah, so it's just like generating a lot of logs, failing some network stuff, but again, it's just pushing out all the logs and other stuff it needs to do. I could also take a look at kubectl. What else is there? The operator. So you can do stern CubeArmor operator -n CubeArmor. All right, these are all the stuff coming from the operator. Operator is constantly looking at the status of all the CubeArmor things and keeping them up to date. So we understand that part. And the final one is kubecontrol get ds-n CubeArmor. You would see that I have this container that is created that is 3 copies and 3 ready. So if anytime I were to like shrink my cluster by deleting a couple of nodes or added more nodes, this will scale up accordingly so that every node has 1 copy of this particular application running, which is the BPF probe in this case. All right. So with that, I'm gonna just like continue on and try to run the example they have. I also have the KubeArmor CLI installed. So if I do KubeArmor version, I will see that I have 1.2.1, which was published on March 27th. So this is the latest, which is cool. Let's go ahead and run the example they are asking us to run. So what it is doing here, in this case, they're creating a deployment called Nginx with the image Nginx, which is one of the most classic example of deploying any application to Kubernetes that you can have. And then next, they are creating one variable called pod, which is grabbing the name of the pod that is going to spin up because of the Nginx deployment. So if I do kubectl get deploy, I would see that I have one deployment is about to get ready, which is currently running. And if I were to do echo, if I do kubectl get PO, I have this Nginx 7854, the thing's name there. I could also say echo $pod. That did not do it. So let's run this one more time. Okay. For some reason, it did not set the value there. But we just did it again. Now the value is set. Yeah, we want to target the Nginx pod in many use cases below. Now, the first thing we want to do is I want to deny my container that is running to have access to things like apt or apt-get. This is one way. If someone gets privileges, someone gets access to the shell of this particular container, they could run apt install to install pretty much anything they need. And if they can install anything they need, they could do other things to the cluster, which we don't want. So this particular KubeArmor policy will help us stop that from happening. But before we do that, let's just run this without. Okay, if I run this without, I can see that I set up all this stuff, mass scan, which probably lets you scan the whole network topology of what the container can see. And if I do kubectl get PO or deploy -n, no, not Nginx-o YAML, you'd see that I have this container definition. I don't really have any other particular policy set. So by default, this one is just running there. I think even not root, but it has a lot of network policy that it probably shouldn't have access to. So let's create this policy. And what I want to do instead, I'm going to create them as YAML so that we can take a look at them after we're done. So what do you want to call it? Let's just call it block apt.yaml. And we created this thing called KubeArmor policy. And what we're doing here is give it a name. So when we list all the policies, we'll get to see what that name is. And the action itself is block. We want to block something from happening. And any process that matches this path, which is /user/bin/apt and apt-get. So this looks like the right thing I want to do. So I'm going to apply this. So if I do kubectl apply -f block apt.yaml, which created a new KubeArmor policy. So kubectl get KubeArmor policy. So there is only one. That's the first one I created. Actually, let me grab the name again. And what is the command we ran there? Let's try this now. Let's try the same command again and see if we can actually get to do the thing again. Oh, good. So we tried this again, and what we're seeing here is user bin apt permission denied, because we are trying to do apt updates. So apt is no longer something that we're allowed to do. And you could do this for pretty much anything. So if you have an application where you don't want people to have access to cat or ls or tree, anything you think of that like lets people get more information about your system than they should, again, you can add a policy there that lets people do things. One thing you might think here, though, like if someone has access like admin permission to the cluster, they could just come in and delete the KubeArmor policy and they'll have all the access again. So this is where your RBAC is your friend, where you could set proper policy who can delete or create and list particular objects. So you need to have proper RBAC policy set up. In this example, again, I, as the creator of the cluster and the admin, I can just go ahead and delete this particular KubeArmor policy. So I can come in, I could say kubectl delete -f block.apt. And then if I go and run this again, you would see this goes back. Because again, the way KubeArmor does things, if we do kubectl get mutating webhooks, you would see that KubeArmor actually has created this mutating webhook. So every time something is going into your cluster, this webhook grabs it, looks at it, and sees whether or not this particular thing has a permission to do X, Y, and Z. So it can change things about your things as your, it can change things about your deployments and pods and other things as you're deploying them with a webhook, as well as you create this KubeArmor policy, the probes that exist on each of the nodes now can also have this policy listed somewhere on their chain. And as you try to do, like on your pod, as you try to do things, it can trigger that probe saying, okay, this particular container in this node, try to access a path that is not allowed and stop it that way. So cool. So that worked. Let's look at the next one. Next one is, oh, okay. So I could take a look at the policy violation. So KubeArmor, the tool, looks, what it seems to do here is basically parse all the different things that are happening, and in a namespace based, instead of me going through individual pods of different KubeArmor pods to parse all the logs, I can just have KubeArmor kind of follow the logs there. So if I'm watching the logs in KubeArmor and I try to do this again and get this, oh, I got rid of that. So that is now working again. So let's apply this again. And then try to, so if I did this again, nothing happens because again, no alert triggered. But now that the block apt is running, I can come and try this again. I will get permission denied. And I should also get a nice little error message here. Let's see if I can print this a little bit nicer. Nope, don't go there. Go there. Okay. Echo -n. Then I can say, oh no, maybe that will work. JQ-R. Oh yeah, that is no. Echo -n single quote double. Then I could do a JQ-R. All right, there you go. Parse that a little bit nicer with JQ, so you could see exactly what the log got created because we stopped it. Ooh, hello, Douglas. Hand waving. Thanks for joining. So we have this timestamp when it happened, exactly how it happened. So these logs, we could also like grab them, put it somewhere else, create alerts to see if some process tried to do something that they're not allowed to. So there's a lot of potential. I also think they have a way to directly plug this into OpenTelemetry, which we'll take a look in a second. But it tells you exactly what happened, what the result is. All of this stuff is all very cool. And this is the first example. So we're going to take a look at a bunch more examples, hopefully, to learn more. So you can get ideas about exactly what happened by having a KubeArmor logs. We want to then look at how do we go about denying access to service accounts. Okay, let's try this one. So what this is trying to do is first create a bash instance inside our Nginx instance, which should be very possible. I could just, I copied too much. Hold on. Let's delete most of it other than the one I want. Okay, this one, oh, it copied in also this arrow. That's not good. All right, if I do this, now I'm inside the container. I have a shell inside the container. And inside there, what we want to do is copy in this curl command. We'll take a look at what this curl command is supposed to do, but let's just paste it first. Okay. All right, so it is sending a curl command to the Kubernetes port at the TCP address, setting an insecure, setting a header, and grabbing the service account token as the bearer token, which should let me do weird things. Okay, I copied it wrong somehow. Okay, let's paste it here. Did it not copy well? What did it do? All right. This does not look right, but I will copy and try this one more time. Oh, sorry. Yeah, it did ran. Here's the API version right here. We get API version v1. Some of the addresses we get out of there is service address and client CIDR. That's the response, I think. Or I could be wrong. Let's see. Does this look right? Can I just send body to curl just like this? I am actually not sure. Shouldn't it be just like something like D and then you have nope. And then I could say here single quote and with a single quote. That does not like it. I mean, again, this is trying to parse this as YAML, so that might not work, but let's try this. Okay. I am not doing this right. That's fine. But the point is, again, if someone has access to the service accounts in your pod, they could go and run commands impersonating certain things. So what we want to do instead is have some policy that stops people from getting access to service token. So yeah, here we go. So let's just make this policy here. I'll say block sa.yaml and create this. And what it is doing is basically recursively stopping permission, blocking any process from accessing this directory, which is run seekers Kubernetes IO service account. So inside your pod, this particular path has been mounted with the service account. So if I apply this, kube control apply -f block. I'm still inside. So I'm going to exit out. And I'm going to say kube control apply -f block sa.yaml. Now, if I do kube control get CubeArmor policy, I would see that I have two of them. And if I were to exec the pod to get terminal and then try this again, Okay. What am I doing? I should be getting started. Service account token. Okay. I tried running something with this, and if I go here and paste this in, you would see that I'm getting a status forbidden. User system anonymous cannot get path/API. Forbidden, that means my bearer token that I tried to get, I got a permission denied because cat, which was trying to read or print out in the bearer token, did not succeed in getting access to the service account. That is nice. And audit access to folders and paths. So this one is less of blocking, more of making sure that things are happening. Oh, I also stopped the KubeArmor logs. So I'm going to run this command again to see what exact error we got here. All right, cool. We got permission denied. We also got a nice little, the actual error we got here was permission denied, CWD and slash. Okay, cool. All right. So what we want to do in the next one is, instead of actually stopping access from it, this time, every time someone tries to access something, we want to audit every time someone does something to in a particular folder. Exit this one, create a new one. I'm going to say audit access.yaml. Cool. Okay, so let's create this one. Kube control apply -f audit access.yaml. Now I have a new particular KubeArmor policy created called audit etc nginx access. I can see that here. I have 3 of them. One of them is the newest. And then let's try to in the okay. So okay. So KubeArmor logs -and default will show all the audit and block operations. Cool. I don't get anything because why? What is trying to happen? Okay, so if I were to just get a bash terminal in here, and if I did cd etc nginx and did an ls, nothing would happen still. Okay, cat nginx conf. I did a cat there. That did not. So what are we exactly stopping here? This did not. I did not really understand what we're trying to do in this one. Okay. KubeArmor annotate namespace default KubeArmor visibility process file network override. So I have to do something before. Okay, so I have to annotate my namespace with setting tag KubeArmor visibility for process file and network. Okay, let's do that. I'm in the pod, so let's do that. So this is now set. Just for good measures, I'm going to delete this thing and reapply it again. Kube control. Delete the audit access YAML and then reapply it again and see if that changes things. Still nothing. Yeah, I'm not sure exactly what I'm supposed to do here, but cat, MIME types. I could do all this stuff. Oh, here you go. Sorry. Yes. Now that is annotated. Now every time I'm doing things, I could see what exactly that was being done there. Alert was created here. File operation was happening. I did an ls there. Cool. I did another thing I did there was I catted the MIME types. Yeah. So you could set up this. You could set up like any kind of audit, and every time someone is doing something from within, you could now create this audit trail. So if you have specific things that you know should not be touched, you can create this audit, and now if something was done there, you will have a way to go trace back exactly what was done. or if something was done at all. That is nice. We also have this, this is running in the background constantly as well. So you could see I'm running 2 different probes, but now you can see audit action was done here a couple times. Awesome. And the last thing in the getting started they want us to know is zero trust least permissive policy allows only Nginx to execute in the pod, deny rest. All right. So this is kind of like if I'm running an Nginx deployment, an Nginx pod, my assumption is I'm doing Nginx things. So I want Nginx to run the Nginx server to serve my static website or whatever we need to do. That means we want to basically stop anybody else from getting access to a shell like we've been getting and doing things in. So what we're doing here, let's just create this and we'll take a look at it a little bit deeper. They're calling this okay. So least primitive permissive policy require one to allow certain actions, operations, and deny rest. So we start with annotating the entire namespace, and that says CubeArmor file posture is blocked. And then we create an allow action. Once there is any Kubernetes policy having allow action, then the pod enters least permissive mode, allowing only explicitly allowed operations. Gotcha. So we're gonna continue letting Nginx do what it needs to do, but the moment anyone else, like again, me as a direct user, tries to access Nginx, so allow nginx.yaml. I did not copy that well. Let's go to here, copy this in. Now we are allowing the Nginx path as well as bin bash, and we're letting this particular pod do it. That's something I'm not 100% clear exactly how that is working. So the action is allowed, the process is these 2 processes, and the path is pretty much the entire root. So from the root, everything recursively, and the selector is for the Nginx. So let's first apply this annotation, which is we're going to annotate the namespace default, which is going to have, I'm going to get out of here, and I'm going to say namespace default will have an annotation that says CubeArmor file posture equals block. They're going to override whatever that was there. So if I do kubectl get ns namespace default -o YAML, we'll get to see what kind of annotations we have on this namespace. So we had this CubeArmor visibility, so that's for the audit, and now we did the file posture equals block. So now if I were to try port forward to port 80 on the particular application, you can see that this is running on port. So if I were to try and open localhost 8080, I would see the Nginx page. That means Nginx has the pod has access to Nginx. But if I try to do anything else, like in the example, they're trying to get access to the bash or change root, for example, I would get missing operand. Oh, so bash. I'm gonna just say ls. This actually let me do things. That does not. Okay. So other than bash and binary, Nginx would be permission denied. So instead of doing bash, what if I did just ls straight up? That works because that is running within bash. So what if I did not allow for bash being there? Let's apply this again. kubectl apply -f audit access. Port forward, see this still works or not. Okay, that works. I can see I have port forward a couple of requests. But now if I try to do this, still letting me do things. Okay. Not sure if that should be allowed. Drop the font one notch. So action is allowed for Nginx, but I don't think bash was allowed. Let's delete the whole thing and redeploy this again. Okay, delete that. Apply this. Yeah, it is letting me do ls. Interesting. Okay. Any binary other than bash and nginx would be permission denied. Let's try to SSH or open a shell into this pod. I mean, these are all supposed to be binaries, right? Okay, what else is there? So you have a bunch of things. Okay, apt is denied, but apt was denied because of a different thing, not for this one. So action was allow. I wonder if like we have multiple one of them, so if they're like fighting against each other. What else could I run from here? So if I did something like word count. Oh, okay. Yeah. Word count does it. Yeah, I'm not 100% sure of how exactly is allow supposed to work. But the general idea seems to be you could start from the most locked down and then give only permission to things that your application needs to work properly. But yeah, I would probably take a look at this again later. But let's move on to other things and see what other cool things AppArmor can do for us. So for hardening infrastructure, you could pretty much install hardening policy directly. So we already installed KubeArmor here already. One cool thing with the KubeArmor tool, though, is KubeArmor can actually give you hardening policy like automatically by looking at your namespace. So if I do default, which only have one application, so it'll come back and probably tell me a lot of things, which you can have actually a nicer view by doing output and call it, not output, sorry, report, call it report dot HTML. So you could say all this report get generated. So I can go to out, this one, and I could just open this. So I can say open out report dot HTML. So this will create like a nice UI view for you to kind of take a look at all the different things your application is currently doing, and that probably should be stopped. And they also give you a severity ranking, which is nice. 10 probably is something that you want to take care of as soon as possible. Lower than 5 is something you're probably looking at audit, or even 1 and 10 is asking you to block them. Yeah, so you have a bunch of these actionable things you could do. So Nginx write in shim, so you could just copy this one in and add this as a security policy because it's recommending. So you could have a bunch of the security policies just created that just that's pretty cool that it just gives you all of these things automatically without you having to know a lot of this. There's a bit of automation that you can set up, as well as you could probably even also set up things like if there are any 10 out of 10 vulnerability or a severity rating of issues, don't let this build pass or don't let this deploy to production or something. But you might also look at this and go like, you know what, this I know what this is and I know what this means. I'm going to allow this because I'm okay with this one. So you get this additional level of control as well as additional level of like visibility into how your application cluster is behaving. Least primitive access, that's the one we were looking at a second ago. So maybe they will have more. This would be permission denied. We did not get permission denied when we did this. Is it because we have other policy? Let's do this. I'm gonna first then try it again, but delete all the policy first. So get rid of make it a little bit upper. So kubectl delete -f dot. Did not spell cube right. Okay, that's fine. So all the policies are gone. So kube control get KubeArmor policy. There is none. So no policy, nothing is allow anything. So I'm gonna just allow the only one that I want to. So kube control apply -f audit access. So that one is now created. Now if I try to do so they're along bin bash. Okay, cool. So chroot one, where did that go? But this is not failing because of the issue is error is wrong. It is failing because, yeah, let's bash do ls. Not sure. I'm gonna try the first command again, the apt one that we now don't have any policy against. So let's see if that actually cleared this one. Yeah, that does not stop it. That is interesting. I might just go ahead and open an issue in a second just to make sure that this is not something an issue on my part, but this does not seem to work as they describe it. Cool. Application behavior. What are other things you could do? So you could control process data, file data, network data, and syscall data. So this could be pretty cool to be able to have policy that stops microservice A to talk to microservice B and B to talk to C, but not from A to C or B to anything else. That could be pretty cool to have this in place as a policy. So a lot of I know people have used things like service meshes to get like network level things, or just things like Cilium or what the other networking stuff. So there is, yeah. So if you have like Cilium and other networking tools that can let you kind of stop these things, you could do that. But it looks like CubeArmor can also do it, and it can do like all the different ones at the same time. It could do network, process, syscall, and file data. So it can be pretty cool to be able to control those. In the advanced block, they actually give a bunch of like use cases what you want to do. So in this one, we already looked at this one. Like you can stop the service account token being accessed. You could do things like make individual folders read-only, or so that no one can go and change things or install new things or delete things from there. So that is good. Other things you have, you are packaging tools. So deny execution of package management tools. So we looked at that as well. So apt, get, make, all of them are, you can just add them all in there. So from this particular one is kind of interesting, because what you can do, you can just have a policy that stops all sorts of different installing tools from being executed. But after that, you can run now this container and this policy in pretty much any Kubernetes distribution, whether or not that is running Debian or Fedora or Arch Linux or anything, because all of the different ones that are possible to be denied are now denied, right? So you're blocking pretty much any type of management process. So the process itself, the policy itself does not require or does not look for this app tool. So if you try to do this where you're trying to kill this app process, you might run into a situation where app does not exist, so you cannot kill it, right? So now this is better because you can now stop it as a policy, which is like almost like a key value pair. So that is useful. Seems like, okay, cool. What else can we do here? We can also you can have trusted cert bundles. Okay, so if someone wants to change your root CA, or this is one way like attackers get access to certain things by if they can change the root CA of your application, all of a sudden your application will start trusting things that they shouldn't. So now you can stop access from changing or writing things, which is again useful thing for you to have. There are more file copy, not letting copying file, accessing databases, no exec. What is this one? Yeah, so if you have any specific tools that you have in the container that runs via your software or something else, you're stopping that. Okay, you're not allowing things like kube control, Docker, or cry control, all of those things. These are useful to have not run. These are good. Capabilities. So these are things like SELinux type stuff almost looks like. What are you stopping? Net raw. I don't know what this capability is. So I don't know. Hold on. AC Linux capabilities. What is netraw? What is netraw capability? Google will tell me at some point. So if you want to, let's an application create raw packets. If you let a process create raw packets, network raw is raw. I was thinking if raw is like some abbreviation, but no, it's just raw packets. If you don't let things write directly to DNS or TCP or UDP, just send raw packets out from the container. That might be, if the container is in a trusted boundary, it might be able to do more things by directly being able to manipulate packets like that. So that is useful to be able to stop it. So the way you go and stop it is just add a policy and say what capability you're trying to match. So any Linux process that is asking for this capability is blocked. So if it tries doing this, so if you try to do things like TCP dump or look at all the network IPs and other things that are existing in that container, those will be stopped. So these are all different use cases that you might be looking into. We don't have much time, so I'm going to just quickly go over some of the other things I kind of quickly glossed over as I was looking at it a couple of hours ago. Looked very interesting. One of them was this, as I mentioned earlier, like CubeArmor can send out these metrics in OpenTelemetry format. That means last time I was here, I actually talked about OpenTelemetry. So if you have not seen that one, go about 3 weeks in the past. There's a video on the same channel that you're looking at. So you can go ahead and take a look at that. Oh, again, that was a very intro level kind of first look kind of a thing for OpenTelemetry. But now if you have this kind of OpenTelemetry format, you could take that and pretty much parse it anywhere you see your logs and metrics. So that can be useful. You can send it over to Prometheus. You could send it over to things like Jaeger if you have spans and other things. So OpenTelemetry format is just a standard format. A lot of tools will be able to parse and understand it. You have all these different fields that are part of your log field. And if you see a field name, now you can come back to this handy table to see exactly what this means and what causes it. Process logs, and you have all the different things for processes, file alert, network host alert, and network alert. So you have different kind of alerts that are created. And again, they're all formatted in a format that OpenTelemetry would understand, which is awesome. Control telemetry and visibility. What does it say? Okay, so you could currently support enabling visibility for containers and hosts. This is, I think, for auditing. You can use the KubeArmor tool, but again, these logs are also being created. So you can either take the KubeArmor tool and grab the logs and send it somewhere else, or you could, it's looking like what they're doing. Okay. Gotcha. So let's deploy this application they're looking for. So what this application is, let's look at the YAML for this before we just randomly deploy something. That's the CubeArmor policy. Cool. So, this is just the same policy we saw. We don't want any apt-get update or apt update stuff running. To deploy, so they can, okay, they have an example of deploying this WordPress MySQL. So I guess it is just going to be a WordPress application with service WordPress deployment. Okay. You know what? That is bunch of things to clone, so we're not gonna go in detail. But again, we saw an example of this already, so you would be able to, if you tried running apt update, it will give you a log as well as audit that. Also stop it, block it, because we have a block action set for anything that is trying to do apt or apt get. That is useful. Okay. Right. So in our namespace, if we were to, again, we don't have WordPress MySQL namespace created, but we could do that on our namespace. In this case, it is called default. We should see, because I think we annotated our namespace a second ago. So you could see that our CubeArmor visibility is process, file, and network. Looks like there is one more, which is process, file, network, and capabilities. So when you enable capability visibility, oh, that's a mouthful. When you enable capability visibility, what you basically get to see is in that namespace is any particular process trying to access any capability. Like one of the one we saw was raw network packet access. And if you want to change it, you just like run and annotate. This is standard kube control stuff, so you could do that. Okay. Security posture. Let's take a look at that real quick. Right. So you could set like a global default posture. For least privilege access in networking, the core tenet of that is you start from the least amount of access required to run your application. So the default mode generally should be block or no. And from then you look at, okay, if I block everything, what breaks, right? So if you block everything breaks, then you start, okay, I'm going to add this one permission and see what happens. At least that's how I think about kind of like least privileged. In an ideal world, you just know everything, exactly what permission your application needs, and you just give those permission and you're done. But even then, that exercise of just blocking everything and slowly giving the least amount of permission needed, it's pretty useful. We do this very similar thing on service accounts on GCP. You start with the least amount of permission you need. So if someone needs to have access to a single bucket on GCS or container storage, to be able to read stuff, you give them access to that bucket as a reader, and then turns out, okay, no, they also need to be able to read the file metadata, which might be a different permission, or they need to write things, that's a different permission, or they need to be able to change the bucket itself, that's a different permissions, right? So you slowly start from the lowest, smallest scope and slowly bring it, make it bigger and bigger. And that seems like a similar thing you are doing here with CubeArmor as well. So you start with network posture, block, audit. It doesn't say what are the different levels. Block and audit. Oh, sorry, two of them. Block and audit. Block is block everything. Audit is just generate telemetry for everything that is happening. It could also be useful for you to run like audit and then kind of see in a day, like in an ideal operation of your application, what are the permissions that are being used, and then go back, block everything and give permission to just those things. That could be easily done in like newer application, but existing application that might already have some security vulnerability, or you don't know exactly if this particular thing is part of the application, this might not work. But you could start off, block everything, look at, not block everything, audit everything in a week and see exactly what are the process that got triggered by your container, then block everything, give permission to just those things, and see if the application continues to function normally. If it does, you got it. If it doesn't, then we have other problems, and we'll take a look at exactly what's happening. Policy spec for containers. So CubeArmor policy. So this is the thing we created. We created small examples, but this is the full spec of all the different things you could have. You could have file permissions level, network capability, and syscalls, and the process itself, what kind of process you're stopping. And they give us a bunch of examples, right? So we took a look at like block type stuff. There is probably some audit, or this action is allow. So it looks like the main three actions are audit, block, and allow. In this case, it could also have policy for nodes, which is only audit or block. And same with examples. Yeah, for nodes, it's just allow or block. All right, so also a bunch of FAQs. So we're going to kind of end here. If you have, obviously, FAQs, go to CubeArmor FAQs and see if that covers your question. If you have any question for us in general, drop it in the comments. This video will be live on YouTube in a second, so you could do that there. If you have any question to me directly, again, you can find me on the internet at Mofi Codes. So yeah, post your questions. We're gonna be back again next week with a different presenter with a different topic. But other than that, it has been wonderful hanging out and looking at CubeArmor with all of you. And now I'm gonna pass it off to the magic person in the background to take us off live. So thank you so much, and see you when I see you.